Goats have been a crucial part of human agriculture for centuries, providing milk, meat, and fiber. But in recent decades, a hidden aspect of goat farming has emerged, one that combines science, technology, and animal husbandry: semen collection. This practice is essential in improving genetic traits and ensuring the continued vitality of goat populations.
Here we have 4 breeds of the bucks. We have Toggenburg, Alpine, Semen, and Aglo-Nubian.
Goat semen collection is a specialized procedure commonly used in animal breeding programs, particularly in artificial insemination, AI. The process requires skill, care, and proper equipment to ensure the collection of high-quality semen. Here's a general outline of the procedures for goat semen collection. The Kenya Animal Genetic Resources Center is taking a bold step in transforming the country's dairy and meat production through the introduction of artificial insemination technology for goats.
We have the code, we have the name, we have the breeder, and then the date of birth. And this one basically helps us when we are doing the straws. We also replicate the same. We feed these bucks with pellets. We also give them hay, adlib. There is water. We also give them potato vines. We also vaccinate against various diseases like FMD, Rift Valley fever, anthrax, so that when the semen is collected, we don't have any variable diseases that can affect them.
Before the buck is presented for semen collection, the selected buck must be healthy, with no signs of illness or injury. The buck should be at a sexually mature age, typically around 6 to 12 months. First, the buck is brought into a specially designed collection area. This area ensures that the animal remains comfortable and relaxed, which is essential for successful collection.
The apron is to be tied in front of the penis to prevent it when it is mounting the teaser, to prevent the semen from being contaminated. This is the place where we do collection. This is the teaser. It has already been restrained. From there now we'll have to bring the buck. After bringing the buck, it will be teased for twice, and then the semen will be collected.
It's called the AV room, artificial vagina room, where we prepare the AVs, where we fix the cone, where we pour water, like what is boiled like this way. You make sure then it is tightened with this knob. We bring it to the oven at a temperature of 60 degrees centigrade. They can stay overnight for tomorrow's collection. This is the collection tube. It has been fixed. You put a lubricant here for easy penetration of the buck penis. Then after that, it is covered for collection to avoid sun rays. So with this one here, is ready for collection. Now what he has done is actually teasing to prepare to collect a nice sample.
As the buck mounts, semen is collected into a sterile container. It's a quick process, and the buck is not harmed in any way. After collection, the semen is immediately processed.
We have now collected slightly 2 ml. I bring the semen to the lab for evaluation. 2 ml. You remove the water. It has to be washed to be removed if there was some tar. Now this one goes for sterilization.
the first thing that we normally do is to examine the semen through the naked eye. That is microscopic examination. Now you look at the semen sample, you see whether it has any contaminants, like blood, hairs, feces, or anything else that is not supposed to be in the feces. You also look at the color. Now, the normal color of semen is cream white, cream white. Now, if at all, let's say you have some other colors, abnormal colors, like let's say it's reddish or bluish or whichever any other color, then you know that semen has been contaminated. So, and if at all, let's say the semen is contaminated or it is having any other color, then you discard that sample, the whole of it, you do not process it. But our sample here is okay. The color is okay. You also confirm the what? The volume. The volume here we have collected 2 mLs. Then after that, we take a drop from the sample and we put it on a microscope slide. We make 2 drops. On one drop, we put a cover slip, and the other drop, we don't put a cover slip. You examine the one without the cover slip, you examine at the raw power objective of the microscope, and you are checking on what you call the wave motion. If the semen is very nice, you see very strong wave motions. If I thought it has having a lot of dead spermatozoas, then you end up having no motility at all. So you end up having very weak wave motion or no wave motion at all. So such a sample, you discard it, you discard the whole of it. Then after that, you examine the other drop at a high power. That way, you are going to see the progressive motility. You are going to see the specific spermatozoas, the way they are moving. Now, generally, the spermatozoas are supposed to move in a forward progressive motion. Now, if at all, let's say the spermatozoas are arrive, but instead of moving in a straight line, they are moving in circles, that semen is not good. You can also check what you call the morphology. Now, spermatozoas have what you call the double tails, for example. If at all, let's say a lot of them have double tails, then that semen sample is not good and you discard it. Now, after examining that, after doing that bit of quality control, the next step now is semen. You want to determine the number of spermatozoas in that particular semen sample, which will guide you on the number of straws or the number of doses that you are going to prepare from that.
Now, after the semen has been satisfied is okay, from evaluation point, the next stage is to measure the concentration of that semen sample. What we do here, we measure 3.99.0 microliters of sodium chloride with 10 microliters of semen sample. This is the 3.99.0.0 of sodium chloride. And this is the spectrophotometer. So I take a semen sample of 10 microliters from the semen collected, the 10 microliters, the sodium chloride. It has to be mixed thoroughly. There is a blank sample for this setting. I remove it, I put it aside, then I put the one which has the semen sample inside. It has been mixed with sodium chloride. Now I start measuring the concentration by keying in the volume of the semen which was collected from this particular bag, which was Juma. It was 2 ml, and it will also give us the number of doses, the volume of the extender we are supposed to add to that semen sample so that we can get so many number of doses from that particular semen sample. The concentration it has given here from this semen sample is 3466 millions per ml. I also recorded the same information I get from the spectrophotometer. The bag name is Juma. Ejaculate was A. Concentration is 3466. Now I go back to the spectrophotometer. Now I wanted to know how many doses has been gotten from this concentration of semen sample. I've got 63 doses. I record here 63 doses. The volume of the diluent I'm supposed to add, I go back. The volume is 13 ml. I also record the absorbance. Now the spectrophotometer, they has given me a total of 63 doses. How do I get the 63 doses? I have to extend the semen sample by 13 ml of the diluent, or the extender, which is here. Two ml plus 13 will make a total of 15. What we do next is to take a semen sample from the diluted semen to see whether the motility has been maintained after adding the diluent. This is just a drop I've put on a slide.
We take a second drop from the diluted semen and we put on a microscope slide, and we put a cover slip, and we examine under a microscope to see whether the motility has been maintained or it has changed. Now, if at all, let's say the motility, still it is a process of quality control or quality assurance. If the motility has gone down below 80%, we discard the whole of that ejaculate. If it is above 80%, then we process the semen further. Now, so the semen goes to the next step of processing. So that is now the wave motion. So after that, now we change and we examine the one with that cover slip. Now this time loud, you can see now the specific spermatozoas. You can see progressive motility is over 90%. This is the motility after dilution. And you can see the motility is very good. You can see the spermatozoas are moving in a straight line. So the motility in this case is around 90%. And therefore, the semen is good for processing. So the next process is printing of the straws.
What happens at this point is labeling of the straws. The information about from the bull that from the back that we collected from the semen is transferred to the straws. So the straws are these ones. These are the straws. 0.25 mLs. And the information that is normally labeled here is the code of the center, the initials of the center, that is Kagrik, the date when that semen was produced, and then you select also if it was ejaculate number 1 is A, if it was yes, then the name. I've indicated the number of doses that we are going to make out of that ejaculate. So it's 63 doses. Then I go ahead and print. So the information is sent from this computer to the iris machine. This is the printer, and is able to print 003 Kagrik, date of when the semen was produced, Kenya Stud Book, registration number, Alpine, KA006A, and then Juma at the end of it. So once we've done the printing, then we arrange the straws, the printed straws. We go to the filling. Okay.
The next step, I'm going to fill the semen which was produced, Juma. I'm going to fill into these straws and seal it. So this is the diluted semen which was produced. So I'm going to put it here. So after putting there, I come and fill. So I put here. And then I start this machine, this filling and sealing machine. So I will, so you see, so it fills and seals the semen which were produced by Juma. I have filled and sealed using this machine. So you see, So after this stage, I come and arrange it in this rack. This arranging rack, and then I transfer the straws to the fridge. And then I put it here.
We normally set it at 4 degrees centigrade. The purpose of keeping the semen in the biobase refrigerator is to make sure that for 4 hours is to make sure that all the semen samples come into that temperature, because that is the temperature we normally start to freeze from.
After chilling of the semen for 4 hours, the semen is frozen using in the digit pool, and the program is automated. This is the liquid nitrogen tank that is actually connected to the freezer. So we introduce the semen at 4 degrees, and then we run the program. We start. After 10 minutes, the semen will freeze to negative 140 degrees. Finally, the semen which is in the freezer will be collected and submerged in liquid nitrogen at negative 196 degrees. Once we've done the freezing and stored the semen, there is a quality control that is done the following day. Anything that has a percentage motility of 50% and above, the semen is kept for distribution. But whatever that is below 50%, the semen is discarded.
After an overnight stay in the freezing container, the following day, we do quality check by doing what we call thawing. We take one straw from each of the straws frozen, from ejaculate A, B. So I will remove the straw from the water. The semen is already stored. I wipe all the water, make sure that the straw is dry from outside. Then I just cut at one end, which is heat sealed, and I empty the whole contents to one of these thawing tubes. I've put a drop on that microscopic slide, and I've covered it with a cover slip.
By thawing, we put it in a water bath at 37 degrees centigrade. Then we wipe the straw to remove the water, and we make a drop. After that, we examine that drop under the microscope. If the straw shows the motility below 50%, we take a second sample from the same ejaculate, and we examine that second sample at the microscope after thawing. If the motility is still less than 50%, we discard the whole of that ejaculate. If the motility of semen, that semen is above 50%, that semen is good, and it is now kept in the lab for at least 1 month. We say we quarantine that semen in the lab. Now that semen is the one that will quarantine, and is the semen that will release to the field for insemination.
When the customer comes, the customer first goes to the accounts where he's cleared and given the necessary documents. The order is run through eCitizen. After that, it's when he comes to pick what he has paid for from this point. So basically, it's only a dispatch point to the customers.
Behind every healthy herd is a team of professionals dedicated to ensuring the success of breeding programs. Goat semen collection at Kenya Animal Genetic Resources Center is a blend of science, compassion, and careful management, all working together to shape the future of goat farming.